Imagine a snake longer than a bus and heavier than a car. And no, this isn't something out of a sci-fi movie. Today, we're going to dive into the story of the single largest snake to have ever slithered on planet Earth, the mighty Titanoboa.
So, our story kicks off deep underground in Colombia at this absolutely massive coal mine called Cerrejon. But this isn't just any old mine. It's actually the fossilized remains of a rainforest from 60 million years ago, and for decades it was holding a truly colossal secret. Everything, and I mean everything, starts with a single, very perplexing discovery. You see, paleontologists were working in the mine, expecting to find ancient plants, but they stumbled onto something that they just couldn't explain. Now, this wasn't some big eureka moment. It was actually a really slow burn. If you look at the timeline here, the first hint was found way back in 1994, a weird fossil that everyone just figured was a piece of a tree. It wasn't until 2007, after more of these things turned up, that all the pieces finally made their way to a museum, with their true identity still a complete mystery. So, when these fossils finally get to the museum, you'd think the experts would figure it out right away, right? Nope. Even they were completely baffled. The sheer size of this bone, a vertebra, a piece of a backbone, was just unlike anything they'd ever seen. I mean, it was way too big for a crocodile, and it didn't look like a turtle. So, was it just a fossilized tree branch after all? Something just didn't feel right. To solve this prehistoric puzzle, the team decided to compare the fossil to the bones of giants from our own time, and that's when they had their big breakthrough. And this was the moment everything clicked. They put that mystery fossil right next to the vertebra of a green anaconda, the largest snake alive on the planet today. As you can see, the difference was just staggering. The fossil from the mine was 3 times larger and way thicker. There was no doubt about it anymore. This wasn't a tree. It was the backbone of a snake. So, the big question, just how big was this snake? Well, using that one bone as a guide, scientists did the math, and the length they came up with is just mind-boggling. We're talking up to 50 feet long. That is longer than a city bus and more than double the length of the biggest anacondas you'd find today. And if you think the length is crazy, wait until you hear about its weight. This creature weighed an estimated 1.2 tons. That's as much as a small car, and it's 10 times heavier than any anaconda. A snake this heavy would literally be crushed by its own weight if it tried to move on land like the snakes we know. A creature this absolutely epic needed a name to match, right? Well, scientists gave it a perfect one. Titanoboa cerrejonensis, the Titanic boa from Cerrejon. It was, without a shadow of a doubt, the undisputed king of all snakes. This incredible discovery just opened up an even bigger question. I mean, how on earth could a snake get so unbelievably massive? The answer, as it turns out, wasn't just in its biology, but in the kind of world it called home. You see, the whole secret to Titanoboa's crazy size comes down to a key biological concept. Snakes are ectothermic, or what we usually call cold-blooded. Unlike you and me, they don't make their own body heat. Their metabolism, the engine that powers their growth, is completely reliant on the temperature of the world around them. And this chart right here shows you exactly what that means. The rule is pretty simple. The hotter the environment, the faster a cold-blooded animal's metabolism runs, and the bigger it can get. For a snake to hit Titanoboa's size, scientists calculated that it needed an average temperature of at least 32 degrees Celsius. Just look at the difference compared to the Amazon today. That's a huge jump. So what's really cool is that the snake's giant body basically acts as a kind of prehistoric thermometer. Its very existence is rock-solid proof that 60 million years ago, the world was a sweltering, superheated hothouse. If Titanoboa were alive today, even a place like the Amazon rainforest would probably be too cold for it to survive. All right, so we've got a 50-foot, 1.2-ton snake living in a crazy hot swamp. So what did it do all day? How did this giant actually live and hunt? That colossal weight was a huge, huge problem. On land, the snake would have been completely crushed by gravity. So Titanoboa adapted. It took to the water. It became an aquatic ambush predator, where the water could support its immense body, letting it move with, believe it or not, surprising speed and grace. Its whole strategy was built on patience and pure power. It would just lie submerged, perfectly still in the murky swamp water, waiting, maybe for hours, maybe even for days.
waiting for some unsuspecting prey to come to the water's edge for a drink, and then, bam! It would explode from the water, lock on with its jaws, and wrap its victim in those massive coils.
And the force of that constriction, it's almost impossible to wrap your head around. Scientists figure it could squeeze with a pressure of 400 pounds per square inch. To help you picture that, they said it's like having 2 full-grown African elephants stand on your chest. There's just no surviving that.
So what's on the menu for a predator that powerful? Well, it wasn't bothering with small stuff, that's for sure. Titanoboa hunted other giants. We're talking about huge prehistoric crocodiles and massive turtles with shells the size of a dining room table. It was, without question, the apex predator of its entire world.
For years, all scientists had were those vertebrae, but then a crucial skull discovery confirmed the final piece of the puzzle. The fossil proved that just like modern boas, Titanoboa could dislocate its jaw, allowing it to swallow prey that was several times wider than its own head.
So you have this perfect predator. It was impossibly powerful, perfectly adapted to its environment, and had no natural enemies. So where did it go? Why aren't there 50-foot snakes swimming around in the Amazon today?
The answer is actually devastatingly simple. Its greatest strength, its total reliance on that extreme heat, became its one fatal weakness. The world that had created Titanoboa started to change, and the planet, it started to cool.
This timeline here really tells the whole story. During the super hot Paleocene epoch, Titanoboa flourished. But as the planet cooled, its entire world just fell apart. Its metabolism slowed way down, making it sluggish. The swamps it needed started to shrink, and new, warm-blooded mammals showed up, creating competition for food. For a creature so perfectly tuned to one very specific, very hot environment, this was a death sentence. The very conditions that allowed it to grow to such a monstrous size were the exact same conditions that doomed it when they disappeared. A few degrees was all it took. And that really leaves us with a fascinating final thought, doesn't it? Titanoboa is this stark, powerful reminder of how profoundly climate shapes life on our planet. It makes you wonder, if a drop of just a few degrees could erase a giant from existence, what other profound changes could a shift of a few degrees bring about in our own world?